Hey, how's it going, everybody? I wanted to do a quick lesson on factoring. We talked about factoring early on, and this is going to be kind of a review this week. But I wanted to go over this idea of factoring out the greatest common factor. And so we're going to start with some basics, and we're going to redo some stuff we did before tomorrow and the next day. And probably I'll talk about it in a different way than I did before, just in case the way I did it before was still too confusing. But for today, all we're going to do is talk about factoring out the greatest common factor. And I'm going to show you a trick for how to find the greatest common factor between two terms, which you can use if it helps you, but you don't have to. And we'll start with an example that has two terms, a 36x and a 30. So I'm doing 36x minus 30. And I guess really I'll put the x in here, but I'm looking for all of the factors of 36x and 30, and then I'm going to use this Venn diagram here. And the Venn diagram is nice because the part that they have in common is going to be my greatest common factor. So if you take these two, for example, 36x, and you do like a factor tree, I know it's 6 times 6 times x, but the 6 and the 6 are each 2 times 3. And then times x. So 2 times 3 times 2 times 3 times x. If you rearrange everything in order, starting with the smallest number to the largest number and end with the variables, you can write what is known as the prime factorization of the number. So 36x, the factorization is going to be 2 times 2 times 3 times 3 times x. Those are all the factors. So I'm going to leave those there. Then I'm going to do the same thing with 30. And I'm going to need to give myself some space here. So for 30, that's 5 times 6. But 6, again, we said was 2 times 3. So 30, if I write all these final numbers in order, I get 2 times 3 times 5. Now what I'm going to do for all of those factors is I'm going to go ahead and circle the ones that are in common. So they both have a 2, they both have a 3, and that's it, right? That's what they have in common. So when I go ahead, I'm going to put all that information into my Venn diagram, and the part in common is going to be the 2 and the 3. So that'll go here. And then for 36x, I need to put in the 2, the 3, and the x still. And then for the 30, I still have a 5. That way I've got all of the factors in my Venn diagram, and now I know the part that's in the middle, or the part that I circled here, is going to be my greatest common factor. And so to factor this out, I'm going to rewrite each of these terms using my greatest common factor. Now the greatest common factor is 6. So maybe I put that down here. GCF equals 6. That's 2 times 3. And now I can rewrite this. Put it down here. Instead of 36x, what's in this circle, I'm going to break it up into 2 pieces. So I'm going to start with the 2 times 3, the 6. And then I'm going to multiply it by these 3 things that didn't make it into the middle. So 2 times 3 times x. That's 6x. Minus 2 times 3 again, so 6 again, times the part that didn't make it into the middle. Now to factor this, I've got a 6 and a 6. I can use the reverse distributive property. So this is all equal to 6 times what's left is 6x minus 5. And then I've just factored that polynomial. So you can, anytime you've got a polynomial, more than one term, you should always start by factoring out the GCF, because then if there's more to factor, that part in the parentheses will be more simple. Let's do one more. So this one here looks a little more complicated. 14x squared y squared minus 21xy plus 7y. So when I do that, I've got to make a Venn diagram. If I'm going to do the Venn diagram, I'm going to need to make 3 circles. So I'll make a circle for 14x squared y squared, another circle for 21xy, and then another circle for 7y. So it definitely gets more complicated the Venn diagram way with 3 terms, but we can still do it. If I take the 14x squared y squared, 14 is just 2 times 7. And so I can rewrite this factorization as 2 times 7 times x times x times y times y. Those are all my factors. If I do 21xy, 21 is 3 times 7. So 3 times 7 times x times y. Then 7y, it's already in the most factored form. I'm going to go through and just put a circle around the parts they have in common. Well, 7x, they all have that. Oh, I did that wrong, didn't I? They all have a 7. Let's fix that. But it's not a 7x they have in common, it's a 7y. So let me circle the 7 and one of the y's. And then down here I've got 7y. So that's what's going to go in the middle. That's this part in the middle of all 3. And then for every other circle, I've got, there's nothing left in this bottom circle, the 7y was it. When I take out the 7y here, what do I have left? A 2, an x, and a y. And then this one here, what do I have left? A 3 and an x. Well, I already put an x. Another 3. That does get more complicated, but we're getting close. Now, if I want to factor all 3 of these things, I'm going to get 14x squared y squared. Well, I'm going to start with my 7y, that thing in the middle. That's the GCF. So I'm going to put 7y times everything in this circle from the 14x squared y squared that's not in the 7y. So what do I have? A 2, an x, another x, and a y. 2x squared y. And then minus, this was the 21xy. I've already put the 7y in there. I need to now write a 3 and an x, so minus 3x. And then my last one, there was nothing else besides the 7y, so I'm not going to put a 0. I'm just going to put a plus 1. And that's my final factored form. And if you think about it, if I take the 7y and multiply it back by each term, I will get my original polynomial back. And it is now in factored form. And let me leave it so you can see the whole picture.